So today's topic is SSL decryption. So we are going to see how Wireshark can decrypt the SSL. So I want to give you a strong background about SSL and TLS. To start with SSL. So we all know SSL stands for Secure Socket Layer and why it is used. And earlier, before HTTPS, all our connection is over the HTTP. The problem is when you try to follow the stream, you can see the complete data, that is the raw data that is visible, human readable. So that is vulnerable, and anybody can follow the TCP stream with HTTP, and they can exactly see what is the exchange, what all the information that's being exchanged between source and destination. So to overcome this, they have come up with a protocol called SSL. So when the connection establishment happens between source and destination, we all know that first it's the layer 4. So we should see a successful SYN, SYNAC, and ACK from the client to the server. So once this is successful, there comes your SSL handshake. And before that, what is the purpose of this? So whatever website you open up, that is mostly with HTTPS protocol. So the S stands for security. And we all know that, so once this in the SYN, SYNAC, and ACK, the information that's being exchanged or 4-tuple connection. My source port, my source IP address. The same way, it's a destination port, 443, and destination IP address. So once this has successfully happened, from any browser, when you open up, the very first request it goes is the very first exchanges from your DNS. So we all know from the packet level, from the DNS perspective, so it is a standard query from the client, and I should get a response back. The query response. So example, if I want to go to www.youtube.com. So the very first thing you will do is you'll go inside your browser. You're going to type the youtube.com. The first request to your DNS request. So I don't know the IP address of youtube.com. Then my layer 3 communication will not happen. So if I hold this record, so for the very first place where it checks is it will check inside my browser cache. Is that I have established a connection before with the same youtube.com. And if it is there, then for my query, it will be responded locally within my browser. So if it is not, then it will look for host record inside my C drive. And if I couldn't find that, then my queries, this is called recursive query. So my query goes to the local browser. If it couldn't find, then it will go to the host record. Then if I don't find the host record information, then my query will go back to the public DNS. Or if you have your LDNS server, local DNS server, inside the local DNS server, you have the record. But now I know I'm going for youtube.com. So what happens? There will be a forwarder in your infrastructure, that is a DNS forwarder. So if you look at the DNS architecture, so I'm not giving it more detail about DNS, but here, so the request goes to the LDNS, and inside the LDNS, you always maintain a cache in your root server. So inside your root, if there are many requests that goes for youtube.com, so the name will be resolved back to the browser from the name server. And but generally in the home internet, we don't own the DNS servers, so the request will be forwarded back to the ISP. And the internet service provider, they have the same kind of setup. They have the name server, and if they don't find any cache information for youtube.com, the query goes back to the public DNS, and it'll get the information back, and my DNS query will be resolved. So this is the very first packet it goes. So now in the use case, so I got a request back from the DNS. For the DNS query, I got a DNS response back from the public DNS. And it says for youtube.com, I got an A record that is name to IP mapping. So my query is responded back, and I know how to reach youtube.com because I got an IP address of youtube.com. So my DNS request is successful now. So what is the next protocol that comes in? So now my IP communication happens successfully. We know source IP and destination IP. I got it. So source IP is my client PC. And the destination is destination IP address. So now the challenge is I know the destination IP address, but I don't know the destination MAC address. Then the ARP request happens. For the ARP request, I got an ARP response back. So now DNS done and my IP communication done, and I got a MAC address. And yesterday we saw that without if your client is not resolving the MAC address, then your packet will not be forwarded. So now my information has been, I got layer 2, layer 3 information. I got layer 4 tuple connection happened. So then actually your TLS comes in. So all this information, and top of that, I have to encrypt all my information, and I want to send it across to the destination. So I'm going to wrap up all this information. So it's a secure tunnel. So there is there are 2 tunnels that's been established for this. Typically, there are 2 tunnels for TLS handshake. One is from client and another one is from the server. And all the information that's completely encrypted. So if somebody is doing a man-in-the-middle attack, they cannot see anything inside. But to do that, so what is the identity I have? So there comes your certificate. That's kind of an authentication, or I would say it's an integrity that nobody's tampering this, and it's kind of an identity on both end. The client and server is showing that, okay, so I am coming from this, and this is my certificate, and you got a certificate. Can you show your certificate? And I'm going to check, and I got my root certificate, and the Google is an authorized website, or it's a Google is an authorized server. So I'm going to validate your certificates. And once the validation is successful, then your actual data transfer happens. So this is not the case for HTTP. So now let's see how exactly the TLS handshake happens. So in the TLS handshake, what exactly happens during the TLS handshake? So from the client, it will specify what is the TLS version I'm using. So in most cases, if there is a TLS version mismatch, your connection will not be established. So now my IP communication done and my TCP is done. Now it's a time for my TLS handshake. So in the TLS handshake, so the very first thing is client, it's going to propose the information. So what are the information that's been encapsulated inside? So it's going to specify what TLS version I'm going to support. So it's going to say, I will support TLS 1, TLS 1.2, and TLS 1.3 examples. And if the same TLS version is not supported in the client, your connection will not be successful. That's your TLS communication will be, failed. And the second thing is, what is the cipher suite I am going to exchange? So what kind of algorithm I'm going to use? We'll see that in the packet capture. So here I will use what kind of version I'm going to use and what kind of cipher suite I'm going to use for my communication, and how I'm going to identify the server using the server public key. So this is important. So how I'm going to validate you using the server public key. And once this is exchanged, so I'm going to generate a session key. So 4 parameters, my TLS version, my cipher suite, and I will use my server public key to validate your request. And I'm going to create a session key. Because when using a session key, I'm going to make a symmetric encryption after the handshake is successfully happens between client and server. So what are the messages that's been exchanged? So very first request from the client to the server is client hello. So inside the client hello, as we discussed, I'm going to specify my TLS version. And for the same client hello, the server is going to respond back. So inside the server hello, it's going to specify its SSL certificate that's being used. Then the authentication happens. The client verifies the server SSL certificate with the certificate authority. Who is that? The root CA. So example, if your browser has a certificate, so you can check your browser certificates. So what are all the valid certificates? So it's going to say the CA, we know it's certificate authority. There are some well-known certificate authorities like GoDaddy and Norton CA. They're all they're all the certificate authorities. That is something, okay, if I want to have a public cert, so what I will do, I'll fill up my CSR. So inside my CSR, I'm going to define what is my organization, what is my DNS name, which country I am from, what is the state information. I have to fill up all this information and what is the algorithm I'm going to use. And all these key values, you will fill it. That is called certificate signing request. And you will send this to the certificate authority and they will sign your certificate. That's something like they're going to stamp. So I authorize this and they will give us certificate and I'll install inside my server. So in the same way, the Google server, it got a certificate signed from the CA. So when the server is telling that this is my certificate, how I'm going to authenticate, I'm going to compare this with my browser certificate. This confirms that who is the server, where it is coming from, and who's the actual owner of the domain. So you specify everything. What is your domain name and what is your state information, from which organization you're coming from. All this information that's been filled inside the server certificate. And so once I get that and I'll compare with my browser and I'll validate and it is a valid, then your client and server hello is successful. The next thing is the client sends one more key information that is called pre-master secret. So this pre-master secret is encrypted with public key. And this can be decrypted with the private key by the server. So this pre-master secret that's shared from the client to the server, and it encrypts with public key, and only with the private key on the server, it can decrypt. So somebody if they're trying to tamper, or they're going to, they're going to tamper this packet. If they try to manipulate this, they cannot do because they do not have a private key. Only the server holds the private key. So I got this public key. So I'm going to encrypt this and only the server can decrypt it because it got the private key, but not anyone else. And once this is done, both client and server generate a session key. Because for every session, your session key is different. So if you open your browser and if you access google.com for the very first time, so your session key number is different. And if you open up the second session, your session is different. Until you kill this session, you have that session key. And this is a random number from both client and server. Then once this is exchanged, the client is going to send a client ready message. That is encrypted with session key. And the server sends the same finished message encrypted with the session key. It is just to prove that, okay, this session is valid and it is happening between you and me. So this complete communication happens with the same session key. And this process is called asymmetric cryptography. Why it is called asymmetric cryptography? Because I use my public key to encrypt. You use your private key to decrypt. And this process is called asymmetric because we are not using the both key. This is how exactly the TLS handshake happens. And we had some challenges with SSL. It got so many vulnerabilities, so that's been completely deprecated. And now only the TLS used. And as far as I know, in a TLS 1.0, that's all deprecated now. That's very old version. And now I think we are using TLS version 3, TLS 1.3. So TLS 1.0 is also deprecated. And if your TLS handshake failure happens, then you have to check the server. If the server supports the older version, then it is not a problem. Then if it is not supporting the older version, then it is a problem for your TLS handshake. Now let's see what we can exactly see in the TLS handshake. So let's see before decrypting how the packet looks like, and after decryption, what is the difference we see in the Wireshark. For that, if you want to customize or if you want to configure your Wireshark to decrypt your TLS handshake, the very first thing you have to do is you have to go to my computer and you have to tweak your environment variables. I'll show you how to do that. You have to go to your system, advanced setting, and you can go to environment variable here. And this is only for one single user. And if you want to make it globally, you can use system variables. This is a variable only for that specific user. So this is my user on my computer. So I'm using this. So you have to create a variable, something like this. So I'll share the document for the same. So you have to create a variable, something like this. You can give the same name or you can use a different name, but I would suggest you can give the same name for testing. And here exactly your pre-master key will be saved. So I have defined a folder to capture all this pre-master keys when I establish a connection in my web browser. So this is a directory where I save all this pre-master keys when I establish a connection, because I want the pre-master key to decrypt the data from the server, right? My public key. So this is how you have to do it. You have to define under the environment variable. And to check your actual traffic is being captured, you can go inside and you can see all your decrypted information. You cannot see anything here. So every time when you're establishing your SSL connection, you can check your file size, keep increasing because the data is being dumped inside. And I got this debug, and if you want, you can take this. This will give you some kind of information that's very helpful for you. For example, if I type master key, so it says that my SSL master key not found. So this SSL pre-master secret is needed to decrypt your data. So you have to check that. See, it says my SSL pre-master secret found. You have to see a message like this for your decryption to happen successfully. And don't make any modifications for the same. And once this is done, you have to do some configurations, or maybe you have to enable some options in the Wireshark. So if you are using Mac, it is a preference option. That's a separate tab you can see on your Mac. And in Windows, you can go to Edit, Preferences, and you can go to Protocol. And as I told you, the SSL is deprecated. So all we can see is TLS. So you have to go to TLS. So here you can create a notepad file as I told, you can use your debug files. So there you can see actually your pre-master secrets being saved, and you found the key or it is missing. So because with the pre-master only, then we can decrypt the packet. So you have to specify here. So here in the pre-master secret log file, so I have given the same directory, whatever the key log I have created, I'm going to define the same here. So let's see if I delete this. What kind of information I can see from the TLS? So if I go to this particular TLS conversation here, if I go to conversation filter TCP, I see a successful SYN, SYNAC, and ACK. And inside my client, I can see all this information. Let's say this is a normal capture. So what we can see inside the TLS. So inside the server, hello, I see the TLS version. And top of that, what is the ciphers suite I'm using here? And the supported version, it says supported version is TLS 1.3. So now in the same capture, if I go edit, and if I do a preferences, and if I go to protocol, if I go to TLS, and where is my log file? It is in my desktop. And if I go to SSL keys, click on it, open. And if I click OK, if I type TLS now, one minute, actually, I have to see some more details here. Yeah, exactly. So from this packet, this is the best way to differentiate So if I go and disable the pre-master secret, what do I see here? And you have to enable your TLS reassembling here. So it says it reassembles the TLS packets, because if I get a response back from the server, it has to reassemble the TLS conversation. So it has to be enabled here. And if I click on OK with the same capture, all I see is I can see client hello. Only this. I don't see any additional information. I can see only TLS version 1.0 and it is client hello. And I see a server hello with extensions. I think this is something that's been captured earlier and it's showing up, but generally it's all encrypted. All you have to see a very limited information like this. So when I go and enable that back, my exact decryption option and SSL keys open, okay. And I see some kind of additional information, some magic packet and additional header information. And see, it says that my chain cipher spec finished. Now, what is the information I can see inside? See, earlier, it's not showing up what is the HTTP version I'm using here, right? So all it shows, it's a TLS. You can compare one more time. If you're going to remove this, all I see is just a TLS and TCP. I don't get any kind of information, so application layer information. What is the application protocol that's being used for this exchange? I don't know anything about that. But once I enable that, because that's all encrypted, go to protocol, TLS, and if I specify my pre-master secret, so now it shows up my HTTP version here. So I got more details now. So let's see in the client hello, it says this is client hello, and I am using version 1.2, and this is a random number that's been generated by client and server. And this is my cipher suite, and I'm using 4 cipher suites. It's going to negotiate with all these 14 cipher suites, and the server has to have any one of those to establish a successful connection. You got a lot more details here. If you go inside the server name, I know the server that is my request is coming from a Mozilla. So this is a request from the client. So I'm telling the request is coming from my Mozilla. And you can see more information. What is the algorithm I'm using? I'm using hash. I'm using 11 algorithms for it. But if I go back and if I disable this, go to protocol, TLS, if I'm going to delete this, all I see for the same client hello, I think this because something that's been pre-captured. Earlier, it should be just an hello message, that's it. And if you look at, you don't see any kind of information with HTTP. So what is the transport protocol that's been used? I have no clue about that. All I see is just client hello, server hello. I don't know what is the application protocol that's used for my application connection here. Let's go back. Protocol, TLS, and I'm going to use my pre-master secret. And if I give OK, I should see this additional details like my magic packet. That's one thing. So it's a Windows update. And it says I'm using HTTP 2. And my length of the packet. All additional information I can see with decryption. Whereas without that, I don't see anything. All I see is encrypted data, and I don't see anything about the application layer information. So it says that my handshake protocol has been finished successfully. We discussed about that. So this is certificate related information. I can exactly see what is the certificate it's using here. I'm using my root certificate as DigiCert. And this is my system cert is Mozilla certificate. And I can see the length, the algorithm that's used. And it says server hello done. In the data packet, you can see what is the length of the packet. And in the server hello, you can actually see your server information, so where the request is coming from. So let's follow another TCP stream and let's see that. You can actually see a lot more details here. So this is the header information for HTTP, and this is a post request, but I don't see anything without decrypting. So this is 200 OK from the server. So this is an 200 OK message from the server, and you have a lot more details inside. So I can see the date at which the connection establishment happened, the values. So all this encrypted information that's been decrypted now. And one more thing, the very important option you can make use of is, instead of looking at the IP, sometimes you feel it's very difficult where my exact communication is happening to the public. So for that, you can go to Edit, Preferences, Name Resolution, and you have to check this Resolve Network IP Address Name. So your DNS is going to resolve all your name here. And if you're using in your enterprise, you can edit and you can add your DNS servers and you can add your ports. So that's going to resolve your name on the Wireshark. Okay, now, as I told, if I go back and disable this, can I see all this information? I cannot see anything here with application layer information. The application data, all with that, I can see it is using HTTP version 2 and all of the data is encrypted. I don't know anything about server. I don't get any information about the application layer information. So now, sorry, now we can go to some of the troubleshooting. We'll discuss about this more detail. So what are the key things we should know about? So this if you're looking at once you're decrypting and as well as when you're doing an handshake and if you're trying to analyze your packet, you have to look at the error. So it says, the Wireshark says it's a bad certificate. So you have to go to your TLS and you have to go to your record layer here. Here exactly it says server hello done. But if you look at this error in the record layer, the alert, it says exactly here, it says if there is a bad certificate, you will get an alert here. So they made it as a client and server name. So by differentiating your DNS entry, as I told, we know what is the destination I'm reaching. And here I can say, this is my client and this is my server. With the DNS option, you can use it. It's pretty handy to use. And if you got your expired, if your certificate is expired and your TLS handshake fails, then in the same record layer, you have to go to client hello. In the same record layer, you can see your certificate expired message there. It's a fatal error and you can verify. And if you look at this as client, this is server. So here it says, I don't know who is your root CA is. In the same record layer, you can go and it says unknown CA. You have to check your cert there. So here it says handshake failed. So here the handshake failed because the server only supports RC4 MD5, but I don't have that. So it says it's a fatal error, the same record layer, it's a handshake failed because of encryption. So I don't own that particular algorithm in my Cypher suite. So you can look for all these errors and you can check the same. See, it says it's a protocol version mismatch. It's a certificate expired and it's a handshake failure. So as I told you, the very first thing is my TCP handshake should be successful. Then your client hello. Then I should receive a server hello. And the client will do a client key exchange. And I should receive the same server key exchange. And once the data transfer happens, it should successfully close the connection. So the FIN packet, it says that I'm closing my connection here. So this is how you can troubleshoot your problems. This is the most common problems you will face. And with this, and if you decrypt your packet, you got more information on it, and I'll go through that. Now, it's the same thing, we'll try to do a live decryption, but sometimes if my pre-master, I couldn't find my pre-master, then it is difficult to do it. So that's why I got this capture. This is successfully decrypted. Now let's try with the new capture. So I see only the UDP communication happening here. I see a few packets for TLS. So this is how generally it should see. If I don't have the pre-master key, this is the only information I can see there. So for that, let me go and check, is it my key lock file is enabled? It's not enabled here. So I have to specify. So you can create your own profile here. Sorry for that. So you can create your own profile and you can add your profile. But now we are going to use the existing profile, protocol, TLS, to desktop, SSL key. You can see the SSL key file is incrementing. So I'm going to remove this filter. So this is my WhatsApp chat. I logged in my browser. So if I go to conversation filter TCP, I don't see the client hellos here. Okay, I can see that. I don't think we got the pre-master secret. Let me check one more time. Is it my protocol, TLS? It's there. So let me try to establish a connection. So there, where's my Zoom? One minute, I'll share it again. This is my edge. So I think Mozilla was better. So if I try to go to youtube.com, DNS contains YouTube. Go to my DNS. So I don't have my name resolution enabled here. Resolve network IP address. Okay. Why is that it's not resolving my DNS? It's bing.com. So I establish a connection to youtube.com. So somewhere the youtube.com. Save only DNS. This is query response. So see only DNS because that is the DNS server. I'm trying to find a server. Okay, I see here. Let's follow the stream. But our session should be established successfully to see that. Copy a value. I don't think we can do it. So it's a Microsoft, okay. Do I see any traffic for it? Go back here. So I see connection going to conversation filter TCP. So client hello, certificate I see. So okay, for the same packet, if I go and disable it. I think the decryption has been done. So it's showing up that. My connection is freezed. Encrypted handshake message. Edit preferences. Go to protocol TLS. There is no information now. Stop this capture. It's very choppy. Let me open up a new one. Okay, now let me go try something else. Microsoft.com. Sorry for that. I got network issue here. So the traffic is going to Microsoft. I should see DNS contains. So React, Internet. Why it's not coming up? So I see the resolved address for Microsoft. Some random address here. DNS dot query equal. Is that command? Oh, not, let me check. DNS query filter. Microsoft.com. So this is the destination. So IPv4.destination. So if I give IPv6.address equal. So this is again only the DNS server details I'm getting. So I'm trying to find the traffic for this. Microsoft. All application data. No, this is a problem I had even when I tried for a capture. Sometimes if I couldn't find the pre-master key, then I couldn't decrypt. But there exactly for few website, it works. And it should work. Sometimes it could be a problem with the browser, because in some forum they suggested the browser, but I tried the Mozilla for the same, for the successful decryption. It worked for this particular website. And I'll come up with a solution for it. So if I give my pre-master key here, and if I filter for I can see this data for this. I look for an option for the same, but the key thing is you have to have your pre-master secret. Otherwise you cannot decrypt your data. And I tried with Mozilla, it worked, and Chrome and Mozilla both are suggested. You can also try with this capture. And with the troubleshooting steps, whatever we have here, it would be helpful for you to figure out where the problem is. And for this pre-master secret, I'll come up with a solution in the next class. And for now, this is how we can decrypt So we have seen the steps, how we going to decrypt it, and what is the pre-configuration I have to do from the PC as well as in the Wireshark to do that. And it is always suggested to use the name resolution filter, because that would be helpful for you to resolve your names. That's helpful for you to track your information. Instead of names, you get your DNS names. That is very helpful for you. And now then let's discuss today how well you guys understood about TLS handshake. And based on that, I'll give you, even more details. So I don't want to confuse you with the dump, and it's not like more information in a single day and to get confused with TLS. So this gave an idea exactly how the Wireshark is decrypting the packet and what are the information I can see. The main key takeaway is how this TLS handshake happens, what is exchanged in client hello, what is exchanged in server hello. So the version that's been exchanged, then along with that, the cipher suite that's exchanged between client and server, and it should match. And if you see a fatal error for your expired certificate, you can see that. And as well as if you got your, if it doesn't know about your certificate authority, it's going to report as an alert that I don't find your certificate authority and I cannot trust it. So with those capture, you can figure out that. And along with that, we discussed about the certificate expired. And when you do a decryption, you can actually see your layer 7 information. So what is the layer 7 protocol that's been used? And even I can see inside the server information, I can see which particular servers I'm talking to. Whereas without decryption, you cannot get those details. So the very first thing is you have to establish a successful TLS connection with the server. Only then your pre-master key will be stored in your key file, the pre-master key file. That helps for your decryption. And this is you can take a close look about all this alerts and errors. That would be helpful for you to figure out where the problem is. And this is all the key things you should know. First thing, the TCP handshake should happen, then TLS handshake should happen. Only then your application data is being exchanged. And you should see the FIN packet, that is your TCP connection is closed. So all your TLS is encrypted, and both client and server, it maintains two tunnel, one from client to server, and another one from server to client. And all this informations are encrypted and exchanged only between the client and server. That is about the quick overview about SSL handshake. So we call this as a TLS handshake. And we have a couple of details, more details inside. This is too deep. It's about deep dive about TLS handshake. But for now, I don't want to confuse everyone. So I want to give you a strong background about how exactly this exchange happens. And the main objective is how the Wireshark is decrypting this TLS handshake and what is the additional information you see from that. So for now, let me stop sharing and stop recording.